If at all possible, I'd like you to attend the seminar after this class at 2:30. There's going to be snacks after the class. I may let you out a little bit early. So there'll be snacks after this class, and then the seminar is in this room at 2:30. So I guess I'm recording. I had intended to cover the remaining parts of Chapter 5, and then I found out that there were a number of packages that were not installed, and certain problems with even with some of the packages that were installed. And so I decided, now I emailed Steve and asked him to do it, but there wasn't enough time from, he didn't come in until today, of course, and so there wasn't enough time to sort of look at, what's in the text relative to those packages. So I decided that I would sort of flip Chapter 7 with Chapter 5 for today. And I'm actually debating and probably will give an assignment on Chapter 7 at any rate, so that means I can actually give the assignment sooner. So I'm going to flip and hold off until Wednesday for the remainder of Chapter 5. Now, one of the problems we have in Chapter 5 is he has these packages, and one of them I couldn't even find. The problem is that this book was published in 2008 or 9, I forget, and the packages, particularly in Bioconductor, are more dynamic. And so a package that existed 5 years ago may no longer exist, or it may have been merged in with another package. And so we have this sort of dynamic aspects. I personally feel that if you write a book, that at minimum you should have a website where you keep up to date with the changes relative to your book, but I haven't found that to be the case with this book. And so when you write a book that depends heavily on data sets that are published as well as packages, it creates a problem when you're teaching out of that book if the data sets disappear or change, or if the packages disappear or change. And that appears to be part of the case in some of the examples in 5. But at any rate, once I have a time to go through that and see what's there and what's not, we will come back to Chapter 5 and do some of it. So we're going to skip ahead to Chapter 7. We're going ahead in Chapter 7. At this point, that actually refers to a manual, the leash manual that you've already downloaded. It's the last part of that manual where it talks about creating an OR package. So what we're going to do today is look at the different aspects of creating an OR package. And you can do that for either S3 or S4 classes. So if you've created an S3 class, you can create a package for that class. And whenever you download a package, this is what people had to do. Although we're going to kind of do this on the low end of it. We're not going to do all the bells and whistles that you might do if you had a real package. And we're going to do that on linmod, which was the example that we had looked at before. And in addition to that, you could also create packages, as I said, for S4 classes with a similar strategy. So there's no handout other than the fact, well, let me show you what the handout is. If you go in, let's see. So if I get a new window for Safari and go into the course, what I'm talking about is this creating OR packages. I'm talking about that particular document. Okay, so you might want to download that again to sort of go along with what we're going to be doing. So let's do the option key. So this is the handout that we will be referencing. So let me make this a bit bigger. I don't know why I didn't index it. It's like one statement of code. It really drives me crazy when it's a whole book. I mean, if it's 20, 30 pages long, you can scroll through it. But by indexing, I mean over here, it breaks it up by section and chapter and so forth, which makes you get to where you want to go much more quickly than scrolling through. In this case, it's only 20 pages, so that's not too bad. So at any rate, just to quickly talk about what we did here. I still feel this is one of the better tutorials out there for creating. He called it creating OR packages, but what he does first, if you look at it, besides giving an introduction, he develops the R code for linear regression. And this is the matrix algebra formulation. And if you recall, he created this utility function called linmod_s, which does the actual estimation. And there he returns a list with the various quantities that you may want to compute, like the coefficients, sigma, and so forth. And then he goes into object-oriented programming and talks about S3 and S4, but then only does S3 classes in this particular paper. Now remember, I did talk about his other work on S4 classes. He goes through a little bit about the S3 system, but then he gets into classes and methods for the linear regression. So this was one of the examples. Remember, the t-test was another example that we did for S3 classes. And then I gave you the one way. So that's sort of the backdrop of this. So what I'm thinking about doing is you had this one way, which you developed in a similar way to this, where you developed the S3 classes and methods for the one way. The question is now, how would you take that and make it into a package that in principle you could put up on the archive, or you could use as a package? So, for example, almost every book that's being written that uses R will have a package associated with the book. If nothing else, that package will have all the data sets, so you don't have to type it in. So, for example, one of the books that I'm working on right now is that Statistics for Research, although I'm changing the book so much that I think I'm going to change the title to Statistics for Data Sciences, which is a bit more general. Using R, and maybe R and SAS, but at least using R. And I have a package right here. Now at this point, mainly what I'm doing is putting in the data. But you don't just put in the data, you actually put in a documentation file which documents what the data is. So if you have a particular data set, which maybe is a data frame, it tells you what it is, what the variables are they numeric, are they factors, etc. So typically you give a lot of information about the data set. So it's self-documenting. Then the only thing you have to do is load the package. So you would say library, in this case you would say library SFR, and then you would say data and the name of the data set. That's all you have to do. And if you want to know about the data set, you simply can do a help, or you can look up the help file or the documentation file for that particular data set. Okay, so that makes it very, very convenient, both in terms of writing the book, that it makes it easy to write the book because you integrate the R code directly into the book. How? How are we doing it? Well, you've seen two things. Primarily, you've seen knitr, that is knit-r, where you actually have a .omd file and you have R code embedded within it, right? And that will generate an HTML file. Now, there are technologies we can use that you can take these .rmd files and not only go to HTML, but there are translators that could take you to a PDF file also. But they're not publication quality. In order to do publication quality, you need to do LaTeX and embed R within LaTeX. And the system that's mainly used there is called SWeave. And SWeave is like Knitter, except that you're embedding R in LaTeX instead of R in Markdown. .rmd means R Markdown, which means you're embedding R within Markdown. So both of these techniques allow you to do reproducible research because the code that you analyze, but the textual information that you describe, as well as the code, is embedded within all together in one document. And if you have the data embedded from a package, in essence you have everything. You have the data, you have the code, and you have the text of the paper or the book you're writing, all there. So it's a self-documenting book. It's reproducible. You can reproduce everything, and in principle, if you had a paper, the person reviewing your paper could actually reproduce everything you're doing. So it's not just, when a lot of scientists think of reproducibility, meaning it's reproducible in the lab in the sense that I described the methods in detail. And I could go into the lab and another scientist could follow my methods, go into another lab and reproduce the experiment. But they can't reproduce the analyses unless you have reproducible research. And so that's why these technologies are important. But increasingly, they're also being done within books. Now, as books become electronic, you also, of course, can embed hyperlinks in your book. Not only hyperlinks to go to places within the book to another place in the book, and that's, of course, good because your hyperlink, you no longer, when you have a reference to section such and such, now you can click on it and go to section such and such within your book if it's electronic. But not only that, you can do a hyperlink to the web. So what does that allow you to do? Well, suppose you have a static graph in your book, but it's not really static. But because it's a book, or even an ebook, it's sort of static, right? So that hyperlink could be to a web page, and that web page could, in fact, have the dynamic graphic. How? Well, there are various technologies. One of the coolest technologies is called Shiny, S-H-I-N-Y. And that's actually developed by the RStudio people. And what that allows you to do is on a server and in a client, you have our code here embedded into JavaScript, perhaps, on the web page. And you have also our code that's on the server. And when you interact with it on the client, it actually sends commands to the server, which recomputes things and sends it back to the client. So you have interactive graphics. And that's actually something we're going to be teaching in, for example, Stat 525, that type of stuff. And so it takes books to a whole new level. You don't necessarily have to build, in order to build that into the book, you would actually, and technically you could technically build it into the book, but the problem is it's hard to do that. For example, if you embed a graphics into a book that's a PDF allows you to do an animation. So technically you could have an animation, but an animation is not interactive. An animation simply plays a script. That's not the same as interactivity, where you actually can change what you do. And so you could embed an animation in PDF into a book, into an ebook, but that's not what I'm talking about. I'm talking about interactivity with the data. At any rate, this is just a new paradigm for publishing, or one of the possible paradigms for publishing. So that's a package that I'm developing for a particular book. Well, we went through all these, we went through all the print.linmod and so on and so forth. We went through all these particular functions, which were generic functions for the most part. And so the question is, how do you take all of this? How do you take all this and put it into a package? So this starts section 5. So what is a package? Well, let's see if I still have this here. So a package bundles this all together, and it gives you access to the functions, it gives you access to data sets. And if you load the package simply by using the library function, you have access to all the functions that are exposed within this package. So you might ask, well, how do we do that? Okay. So today we'll take a look at how do we do this. Now, unfortunately, we have to kind of leave the confines of R and go to the Unix level. We can't do all of this in R. Now, if you run a Windows machine, you will have to load the appropriate tools. And on Linux or the Mac, they should be there. Okay, so let's take a look. So packages. Well, you can do the scale. We have a function, or you may have a function, and perhaps, file, which has all of the linmod functions in it. Or maybe you have several files that contain it. Maybe it's not all in one file. But let's assume that, for now I'm going to assume that we have a file linmod.r or something like that, which has all of the R functions that you created for your S3 classes and methods. Okay, so we'll assume that. You can actually create the skeleton of a package with a function called package.skeleton. Now, what is in a package? Well, there's a description file which describes the packages. You know, who wrote it. What is the license? Each package can have a separate license. Now, R has a specific package, a certain license that allows the use of that package. But each package could be more liberal or more conservative in the rights that you give other people to use your package. And I'll sort of discuss that information later. Usually you'll give a short description of the package. You'll give its dependencies. Well, what if it depends on other packages? What packages does it depend on? Now, one of the things that you don't want to do is have too many dependencies. Why? Because if you have too many packages you depend upon, and one of those packages doesn't get updated, or it breaks, then your package won't work. So you have to seriously think about which packages you want to put as a dependency of your package. So if your package depends on too many other packages that other people are writing, and you don't even know them, and they don't keep it up to date, you're in trouble. So it's a good idea. It's a good idea to be cautious about how many packages. There are certain packages that have been around forever, and it probably will be for the foreseeable future. So sure, you can have those packages dependencies. You're also going to have various directories. You're going to have a man directory, MAN, which means manual, which is the documentation is all in there. You're going to have an R subdirectory, which actually has all your R code. You're going to have a data subdirectory, which has your data sets. Now, you could have other things in it. You could have source files. So suppose you have C or Fortran code or C++, and so you want your package to be highly efficient. In fact, most of your computations may be done in C++, and so it can be very, very highly efficient. And your R is just basically a wrapper. It wraps the C++ code to make it user-friendly. so that the person using it doesn't have to know C++. It's done in the background. So, and then you could have validation tests. So you have a whole suite of validation tests to test your code. And so every time you update it or you make changes, you run these validation tests to make sure it's still working. This is called unit testing sometimes. There could be other executables like Perl or Java. And then the various other contents. And then you may have, these are all optional. All of these down here are optional, depending upon how sophisticated you are. These are not things we're going to be doing in this class. You could have a configuration script. Okay. So for example, if there are system differences, you could put that configuration script. So the first command that we want to give is package.skeleton. So let's sort of find out where this stuff is. So if I go into chapter 2, I think. Where did I put it? Chapter 3, I think it is, I guess. Chapter 3. Yeah. Here's linmod right here. Okay. So this is the R code that has everything in it. This is the R code that has everything in it. So if you look at this particular file, it has this is the definition of function if use method, and then this is linmod.default, linmod.s, linmod.formula, print.linmod, summary.linmod, etc. Okay, so this is all the code for that particular example. So it's all in one .r file. Now let me see again where I put this stuff, because you actually want a separate directory. I don't have it here. Where do I have it? Trying to remember where I put it now. I thought this was it, but this has a lot of other stuff in it too. Well, it's faster for me to look through this if I go in here and create a connection to the server. Oh, I'm sorry, I already have it. I have it here. And so I'm going to go to courses, 523, notes. I'm not finding where I thought it was. So I think in order to have a clean slate, I'm going to create it outside of any chapter. So I'm going to create a new folder. Let's see. Spelling right. And then what I'm going to do is I'm going to pull this file into that. Okay. Actually, I may want that outside of it. Let me just put it here. Actually, it's going to create the folder. It should create this folder. Let's see. I think it will. Using the skeleton. I'm going to move this to the trash for now. Okay, so I'm going to move to that position back here. So if I go back here, where is it? If I go to courses 523, was it under notes? Yeah. Okay. So let's open this up, and I'm going to set this as the working directory. So I'm going to set this notes. And now what I'm going to do is I need to copy basically this particular command in R, the package skeleton. So if I take this command and I'm going to copy it over here, but that wasn't what I called this file. I think I called it linmod s3. Is that correct? I think so. Linmod s3. So let's execute this and see what it does. Okay. So what it should have done, if I go back and let's go back here and look. It created linmod, so it created that. So now we can move there. We can move there. If you look at this, here it is. I refreshed it. Sometimes you have to refresh it to get it to show, to show the files or the directories. So if I look inside it, this is what it created. It creates a skeletal. So it has a description file, and you basically have to fill in. It says the package name is linmod. It's type package. Title, what the package does, short line, version 1, the date, who wrote it, the maintainer, the description, the license. So you basically have to go in and change that information. So that's the description file. Then by default, it has the R file, and the only thing in the R file is your .R file, the s3.R file. So that's part of the .R file. And then it has, going back to here, it has the manual. Now the manual are what are called RD files. What's RD? Well, that stands for R documentation. And this has a skeletal form for each. So if I look at, for example, if I look at the nmod, if I look at linmod.esc, it gives the documentation for all the functions in it. Okay, so it gives you a skeletal. Now that doesn't mean that you don't have to do a little effort here. You do. Now what we're going to do is only have one function. That is, we're only going to have one file, maybe two. We're going to have one file just for we have actually one file that has all the functions in it. So we're just going to have one descriptive file. We're going to get rid of all the others. Okay. So this is the documentation file. So now if I go, this is the namespace. Remember when we talked about namespace? This tells you which functions you want to expose to the outside world as far as a namespace. or which functions you import from other packages. And this says read and delete me. So this gives you some guidance as to what you have to do. It says edit the help file selections in man, possibly combining help files for multiple functions. Well, we're going to do a lot of combining into one file. Edit the exports in the namespace and add necessary imports. Put any C, C++, Fortran in the source file. Well, we don't have a source file. By default, you don't get it, but you could create one. This is just a directory structure, so we could use a Unix command. In fact, if you mount it like this, once I'm in here, I could actually just go up in the Mac and say make a new folder, and then I could just say it's source, and that's it. But that's all you would have to do here. But we won't do that. You could use Unix commands, of course, to do this. So then you're going to do three things. You're going to do rcommand build, which builds the file. Once you've done all the editing, we haven't talked about data sets, of course, and how do you get data sets in. And there are a couple ways you can do that. And how do you get, data sets is the main thing. So we could also, we could also have a data sets file, or a data file, and then in addition you want to check your code. So R has a way of checking the code to see if it works. And if you wanted to publish your code up on what's called CRAN, that's the Comprehensive R network. If you want to publish it there, it has to pass the check test. Okay, they will run it. And if it doesn't pass, you will not get up on their website. So in other words, and then technically, although there are a few caveats to that, but you not only have to pass it, you have to pass it on all the operating systems. So therefore, you don't want to do something strange that only works on one system. R treats itself as being sort of cross-platform, and therefore, when you write a package, it's your responsibility to make sure that it runs everywhere. Okay. So, of course, what I have I can check automatically Linux, but I also run Windows, and so I can check everything. I have VMware. So at any rate, that's the gist. So the skeleton gets you a long way, so at least you get you the template. But unfortunately, there's still quite a bit of editing that you have to do, for this. Okay. Now, in order to do some of this, you have to. Where am I? What happened to my? Oh, okay. Am I running? Oh, this is our studio. Yeah. That's not where I want to be. I want to be here. I was running our studio also. So at any rate, now at a minimum, you're probably going to want one more directory here, which has some data in it. And at this point, we won't do the namespace. We learned a little bit about it. But if you do a package, you probably should do a namespace. That's a little more advanced to do. We learned a little bit about it, but the namespace is something that you probably should do. Certainly, if you publish it up on CRAN, you should do a namespace. The reason you want to do it is because if you use it, there are thousands of R packages, and you don't know what names other people have used. And so in your coding, you're likely to use some of the same names as other people have used. So this allows you to keep the same name tied to a package, so that my names are tied to my package. If someone else has the same names as mine, they get tied to their package. And therefore, you're being a good citizen. Otherwise, do you remember these messages you occasionally get about masking? That I load this package and it says it masks these names from these other packages? that's because of namespace conflicts. So a name and you have the same name. You load a package has the same name in that package as some other package you've already loaded. So you'll mask it. So that's something you have to be careful about. Okay, so this is the structure. This is the structure we have. So how do we go about? How do we go about? Well, if I just tried to run it at this point, it would not like it because it doesn't really have a title. So how do I? You can run it in RStudio. You can do Unix right here. So even on the web, you can just bring up a shell. And so this is a Unix shell, and I could see LS, and I could see, well, I'm actually not in the correct place, right? In fact, I'm not in the correct place down here because I've moved inside the chapter. So if I want to be, well, first of all, you might ask where you are and where do you want to be if you try to be commands. You want to be one level above the directory for linmod. In other words, if I'm going to run a command involving linmod, I need to be above it in the next directory up. So that's actually, so you can check where you are, and you can check where you are, but we have if we look at the directory structure, and let me again bring this shell back a minute. If I look at, I'm going to do an ls minus l. If I look at this, and if I do print working directory, I'm in notes, and within notes, I have a directory called linmod right here. So if I wanted to try to build it, I could just say R command, and now I'm in Unix. This has to be done on Unix, not in R. And you could say build, and then I could say linmod. But it's going to... It worked? How did it work? Oh, this might work, but what it won't work on is where you try to install it. So at this point, you could try to do R command check linmod. And you notice it says installation failed. And it gives you several reasons why that's okay. It goes through this checklist, and it ultimately gets down and it says it failed. Well, there are a couple of reasons why it has failed. So at this point, I'm going to leave Unix. We'll come back to that in a little bit. But that's how you run those two commands. It's very simple. But we haven't done enough. Does someone have to do it? So we haven't done enough to install it. So I'm gonna leave this. Now, there's another thing that you might want to notice, and so we can notice this by going back to notes. There's not only the linmod file, but when I did the build, it created this file. It created a file called linmod_1.0, meaning version 1, and then .tar.gz. And what that means, a tar is an archive file, and it puts all of the files into one place, and then gz zips it. That is, it compresses it. So what you did is you took this directory, which has subdirectories, so there are lots of files there. You put it together in one file by doing the tar command, the TAR. Tar used to mean tape archive. This is back in the day. You probably had never heard of this, where you actually had these tapes, big tapes, and that's how things got backed up. And you had thousands of these tapes. So you had a computer center that was huge. Why? The computers took up some space, but what really took up the space was all the tape drives, where you actually had, we didn't have all these disk drives that we now have. And the ones that you had early on were small and very expensive. So you backed everything up with tape. So TAR stands for tape archive. But now, of course, it was an algorithm in Unix for doing that. The GZ is simply a zip file, which means it compresses it. So we both archive all these different directories that we archive into one file, and it's self-explaining, so it knows itself. You can decompress it and bring back the whole thing. But what we do in R is we can actually install directly from that tar.gz file. We can install directly from there. So, so we have that file, but notice we also have this check file. So this check file actually has an out file that will tell you what's how it did and what's wrong, where the error is, and so forth. And say, for example, here it says missing empty title field. Well, I didn't put a title field in it. So when you check it, that file called output will, the out.out file will give you information about why it failed to check. Now, as I said, if you wanted to put this up on CRAN, you would have to get this working. So this is the process people have to go through in order to get an R. You may wonder, how do these packages magically appear? Well, this is part of the process where they magically appear. Okay. So, so again, going back to notes. These are the four files or directories that we're working with. Now this particular .r file is now embedded within here. It's now inside the package, the original file. So, okay, so what do we want to go for here? Well, I've already done a little bit of editing. I don't want to spend a lot of time right now. I've done a minimal amount of editing. And so, in particular, I have, I think it's under Dropbox. I keep forgetting because under Dropbox, I have the linmod package, and I believe this is actually, yeah, this is a little more, this is edited a bit. You see, so for example, the title is linear regression. I'm the author. I have a little description. This is a demo package for the tutorial creating R packages. Suggest mass, that means it suggests that you load that package. And the reason is that the data set used, called cats, is in the mass package. So to save a little time, let's bring this back. And this is actually on the Unix side of things. I mean, I'm actually on the server now. I know it's a little confusing because I'm working locally and also at the server. This screen, here, right here, which the same thing as here, I'm actually working on connection failed. That's not good. Did I accidentally shut that file? Maybe I did. So maybe I shut it. Yeah, here it is. No problem. So if I go into stat 523 and I go down into linmod and I go into manual pages. No, well, the first thing I want to do is I'm going to actually take this file, which is already edited, and overwrite this file called this. This is the old one. So hopefully I'll pull it the right way, hopefully. So I'm going to take this file and pull it down here. And it says it's newer because we just created it. But it's actually newer, but it doesn't have the information in that I want. So I'm going to replace. Okay, so that's the description file. Now, how might you have done this? Well, if you go back here, to linmod, you can simply bring the description file up here and edit it right here and save it. Okay? So I've already edited this, but you could go in. That's the one I just drug across, but I'm now back in RStudio. I'm in the same directory as I am here. That's the same directory. You understand? And so So I just brought that file up, which I just drug over from my Dropbox account. And so you could edit it right here and save it. And so you can just go in and put anything you want. You need to put, for you need to put your email address here, and some title, some short title, and so forth. Notice the license is GPL2. That's one possibility. Another possibility might be BSD. BSD is actually the title. That's what I like, because it gives the person using your stuff more freedom. It even gives them the freedom to take your stuff and commercialize it, whereas GPL2 does not. So with BSD, the Unix part of the Mac operating system is BSD. In fact, it's called a BSD Unix-based operating system. In terms of Unix, there are a number of Unixes out there, but the original Unix was developed by Bell Labs back in around 70, in that time frame. And what happened was that a lot of people bought machines, mainly not made by Bell Labs, but made by people like Digital Equipment Corporation. And they had the AT&T or the Bell Labs Unix on it. But the academics wanted to develop their own Unix, which was freely distributed. So you think of Linux as being a clone of Unix, but in fact, BSD was a much earlier clone. And BSD stands for Berkeley Standard Distribution. And why? Because it was developed at the University of California at Berkeley, this BSD Unix. And so there are actually there are several variants of BSD Unix. One of the variants of BSD Unix is what's in the Mac. And in fact, theirs is actually a very standard one because it's what's called POSIX compliant. POSIX compliance Unix means that any code that you write for any POSIX compliance machine could run on any other Unix-based machine, which is POSIX compliant. So for example, IBM has AIX, that's their Unix. HP has HPUX, that's their Unix. All of those, and the Mac OS X are, well, it's called OS X now, not Mac OS X. OS X is also Unix compliant, POSIX compliant. So if you write for OS X Unix, it will run unmodified on AIX, on HPUX. Linux is not POSIX compliant, so you cannot guarantee that if you write a Unix program, it will run on OS X or AIX or any of those Unixes. So at any rate, that's just a little history. So you put the license you want here. Okay, so that's that particular file, and so we can save that. So it's saved. So that's the description file. Now I don't want all of this stuff here. These files, I don't want to do a separate one. The only one I want to do is the linmod RD. So what we're going to do is we're going to go in and kill just about all of these. So you're going to kill all these. And so we're going to go in and delete those. So it actually only leaves this one, but even that's not quite what I want. Now, I don't know that I fully edited it, but I have something, whoops, using the wrong number of fingers. There it is. You have to control how many fingers you swipe with. So at any rate, if you go back here under the man page, I only have two files here. I have this file and I have cats for the cats dataset. That is a dataset file for cats. Now, I actually have a file for cats, but I don't actually have the cats dataset in here. And the reason I don't is because it's in mass. It's not one we created. But let's say, what did you run it? What was the assignment? What data set you absorption or was it? Fairway. What? It was Fairway's book. What was the name of the file? What now? Coagulation. Yeah. So suppose you wanted to put coagulation. then you would have to actually put the file in together with the description for the file. So, okay. So, so first of all, what I'm going to do is I'm going to drag this file. So now if I look in the manual page here, notice that the others were thrown away. So I'm going to drag this file here, which is in Dropbox, and put it over here. And I'm going to replace it. Now, I'm also going to drag the cats file. I'm going to also drag it over. Okay. So just to show you a little bit, so now let's sort of see what is what. How did I get out of this? How did I get out of there? Seems like that magically happens sometime. So now when I look at linmod and I look under man, I can bring up this. This is just a text file. It's sort of like LaTeX, unfortunately for you. Basically, for every function you're interested in or any method, you need an alias. So I've got a name linmod, and then I have an alias for linmod, an alias for linmod.default, an alias for linmod.formula, and so forth. So I have an alias for each one of those functions. Now, in addition to that, and then you can give a description with the backslash. This is all the type of stuff you do in LaTeX. The backslash description is just, I think it's optional. It says fit a linear model regression, although I think you want something. And then you have a usage file. So the question is, when you go into R, and let's just pick something. Why is that? Let me resize this. Something's wrong with this. Something's wrong. It's covering up my icon over there. I can't get to it. I'm just going to make it. I don't know what's going on. I've never had this happen before. Okay. What I was trying to show is that, if you type in a function, it's not let me type. I'm in hell. Okay. So if I type in a function summary, then it gives a, this is irritating. It gives a, it says, okay, summary. That says it's from the base package. The user's going to say it's from linmod. If you type in a help with yours, once you install it, and you type in a function name, it will say it's from linmod. That's the name of your package. So this is the base package, and then it will give summary. It will give this, and basically this is the usage, and then it gives the arguments. So what you have to do is you have the usage, and then you have the arguments. So here's the usage. It says linmod xy comma dot dot dot, and then these are the methods. And the way this is done, this is linmod, and then this is for generic functions. You get the methods. So you have linmod, which is a generic function for default, linmod for formula, and now print is a generic method with linmod, and so forth. So these are the generic methods, and that had to be typed in. In other words, you had to type those in. And then you give up above here. You give how the arguments work. So for formula, you give formula data equals list, comma, dot, 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 and so forth. All of them have a comma, dot, 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 because you have a comma, dot, dot, dot in the original generic form of it. And then you describe the arguments. Item X. X is a numeric design matrix for the model. Y is a numeric vector of responses. So, and you have to follow this format. Now, the skeleton that it gives you some of this. It gives you the skeletal form, so it's not as if you really have to learn all that much. And the Leash book describes how you fill in these fields, at least to some degree. Okay? And so, and then if you look over here, you have the usage, and then you have the arguments, and then you have, there may be details here, but you also have the values. So again, the values come in here, including who the author, and then you may give examples down here. The examples appear at the end. So what you're doing is filling in here what you see here for your help page. That's what you have to do. Okay? So, so basically, and we'll go back through this a little bit more next time. I don't know if I'm going to stick on this or whether I'm going to go back to Chapter 5. It depends on how straightened out we have Chapter 5. But at any rate, let's go a little bit longer today. I'm going to let you out a little bit early because we have a seminar coming up. So I'm hoping to see most of you there. So, at any rate, this is how you do a document. Now let's look at the cats file. Here's the cats file, name cats, alias cats. Now the title is anatomical data from domestic cats. And here's a description of this file. And then, so this gives a short description here. Notice this whole thing is description. This emphasis is part of the description. That is a LaTeX thing, or LaTeX thing. And so this particular curly bracket actually connects in with this bracket up here. And then again it has usage, where the usage is this data cats. That's all you have to do to bring it in. And then it describes the format for the cats and describes each of the items for sex, body weight, and heart weight. So it describes each of the variables. So that is how you so I'll give you this information. I'll post this information for you. I wasn't sure what I was going to do today, but since Chapter 5 is not ready, I didn't have a chance to post this. But I'll post it with these files in it. They're not 100% fleshed out, but they basically have it. So, and then you have, a lot of times you'll put in references for the data set. So in other words, if you're using someone else's data set, you're supposed to reference it. If it's a book, you probably have to get permission. If it's published in another book, you probably have to get permission from the publisher of the other book to use the data. It's not enough just to give the reference. So this is an R documentation for the CATS data set. Okay? So this is the gist of how you do a package, at least in a somewhat fundamental sense. So let's go back to here, and here we have linmod, and we now have corrected, well, we sort of have corrected description file. We have manual pages in. You know, we only have the one file for .r. We haven't done the namespace. Okay, we don't technically need this. You could delete it. You could delete that file. I don't think it hurts anything, but you could delete it. And again, the one thing that you're very likely to add to this, which we'll talk about next time, is another directory that has the data in it. So we could take the data they're using in, well, they're using the CATS data, but we could take another data set and we could show you how that works. Okay, so this is the procedure. It's now what I want to do now is go back to notes because I want to be at the right level. There's linmod, and now I'm going to go to tools. I'm not sure this is going to run. let's do ls to make sure we're in the right place. So here's our linmod file. So here you type r command install, and then we do linmod. And that apparently has done it. And then in principle, we should be able to now, if I could get this to work, we should be able to now go in and say library. You won't be able to do this. Linmod. And there it is. Okay? So, I don't know. There's the help. And we should be able to say, help on cats too. Was it cat or cats? Cats? No, that's not. Oh. Oh yeah, here it is. Okay, there it is. Sorry. That's our help. Pretty cool, huh? Should be able to whip this out in about an hour. I'm joking. Some of you will spend days. At any rate, a part of it is you have to know a little bit of Unix to do this. But not much. But you have to be able to move things around the file system and so forth. If you do it in here, you can just drag and drop. So that's the gist of how you create a package. We just created it from scratch. Well, not exactly scratch. We had the .or file, right? That was actually the harder part, creating the .or file. They had to code in it. Now, typically, you might have multiple .or files. In that skeletal package, you can actually have a list of .or files that you bring into the package. And each one of them would be in the R directory. So you could have multiple R files. Or you could actually create it with one and then start adding it. You could just drag them in. Okay. Just like data, you could just drag. Every time I do a new data set, I just drag it into the, the data directory for what I'm creating, the package I'm creating. Oh, I didn't tell you how you create a file. The main way you create a file is using the save command. Use the save command. There's another way you can do it too, but the save command is the most. So you actually use like read.table and you read in the file, and let's suppose it would be called absorption or something, and then you say save absorption, and you have to put the right ending on it. But we'll go through that next time. So I haven't told you how to create how do you create. Right now, we already had cats. That came from mass, right? So you didn't have to create it. But suppose you create a file, you create a data frame, and now you want to create the help. You want to make it available in your package to anyone who uses your package, and you want to put documentation in. So you use the save command to actually create the file you actually need to make it available to everyone else. And then you have to do a .rd file for documentation for that particular data file. So that's sort of the way it works. Are there any questions? Okay, we'll come back to this. On Wednesday, we may do some Chapter 5 and some of this. And then I'm going to write up another, your next homework will be for you to take. I think I'm just going to do it on the S3 class. I don't think I'm going to cover how you create a package from S4 classes. It's not too different, but okay. But the S3 will be easier. So if you didn't get it working, you still probably should try to get it working, or at least get it working to the point where it runs. So, and I know I need to get it back to you. I'll let you know if it doesn't run. because that's the main way I'm checking them. Okay, so this is really, it's really not as hard as you might think to create a package. If you do a thesis or if you do a dissertation, you're a PhD, you're almost guaranteed to create a package. MS, maybe not. Okay? So there is a seminar in about 20 minutes.
What's the seminar about?
It's a little bit theoretical. You might want to get excuse of that. He's a chair of statistics at Michigan State University.
Yeah.
You're welcome to.